So, before tayo mag-start dun sa ating discussion, so lahat naman ng lecture ay naka-upload na dun sa ating Google Classroom. So all the lectures that is part of the midterm exam. Okay. So before tayo mag-move doon sa last na topic natin for the midterm exam, share muna ako ng screen for groupings ng design project proposal. So ito naman is sa ibang section pa. Kakopyahin ko pa yung names nyo dito. So kayo ay 05 na for the 7 students. Okay, so this will be your final group na for design project. Okay, so ito yung mga names nyo na ano. Okay. So, yan. Tama naman, no? May space. Yes. Isa pa. Okay. Yes, Ayumi? Ay, oo nga, no. Saan bang napupunta yung pangalan ni Carl? Sa group 1 siya kasama. So disregard na lang yung andi dito para hindi tayo mag-uulit. Clear ba? Clear na tayo doon? So yung kay Maala Carl group 1 na lang siya. Okay? Okay, for group 1, we have Kyle, Carl, Von, Adriel, Christian, Haven, Nikos, Siluigi. So for group 2, we have Kim, Mark, Miguel, Christopher, Mark, Andre, Alex, Aaron, Justin, Jeter. For group 3, we have Carl, Vincent, Jared, Christian, Hans, Lance, Alex, Harold, John Lloyd, and Daya. Pero ano ba yung Mala? Hindi na nakasama yung Again, yan. Group 1 na si Mala. Group 4, we have Carl, John, Alwin, Cyril, Renz, Leia, Irish, Aaron, Carlos. For group 5, we have Bea, Kimberly, Waris, Ayumi, Aubrey, Alyssa, John Rainiel, Neil, Faith, Jean, Mary Jean, Jean Ira, Ken, Rio. So napansin ko lang, nagsama-sama pa rin may mga pangalang Jean. Wala lang. SKN. Okay. Clear na ba tayo sa groupings?
Yes po, ma'am.
Clear na? You have any question? Clarification. Okay. So, for your design project in this refrigeration system, you need to first submit proposal or proposed design, and then once approved, you can proceed with the design project mismo na na-approve na topic. So we have two parts ng ating proposal ay ng ating design project. So first you will propose, and then the next one after yun nga ma-approve, then you will start na yung design project. So I already uploaded the both mismo. So let us first discuss muna yung sa proposal. So both of these are already uploaded sa Google Classroom. So you are guided on each part na kung ano yung mga ilalagay ninyo doon sa proposal. So for the proposal of your design project, so ilalagay nyo dito yung topic ng gusto nyong i-propose. So you need to include your section, group number, and then the proponents of your group. So yun. Share ko na lang din muna pala to sa GC. So hindi ko lang alam kasi yung kanina ayaw niyang tingnan ko kung magsasend siya ngayon. Or pa-screenshot na lang sa inyo and then pa-share sa GC. Pa-screenshot naman ako dito. Group 1 to 3. Pa-screenshot ako. And then group 4 to 6. Pa-screenshot din. And then kindly share it in our GC. Kasi, ayan, nag-send pala yung isa. Ayan, try ko din pala to. Kasi kanina hindi siya mag-send. Ayan, share ko din. Ayan, nag-share na pala. Share ko na din. Yan. Okay? So, for yan, type na lang dito yung numbers. And then, yan, lagay dito ang proposed design project. And then, here are the contents of the proposed design project. So, we have the introduction, objective, design strategy, plan of action, verification, schedule. Bibliography naman, if syempre meron din kasi kayong ipopropose dito na related studies. So, yung mga references na ginamit ninyo. Yan. Statement on the contribution of each member. So, let's start doon sa part ng introduction. So, ano yung mga laman niya? So, for introduction, what is the project about and what is the motivation? Review any prior work in the subject area. So, yan. Meron kayong review of related literature. Describe in detail functional requirements, preliminary but quantitative specifications, related technology areas, competitive benchmarks, and any related patents. Comment on the scope of effort involved in general terms. So as part of the objective naman, describe the project goal and intended functions and features. You have to carefully state how you have narrowed or broadened the scope of the project based on available time and labor resource. So comment on critical design parameters and what challenges might stand in the way of accomplishing your design objectives. So be ever alert to professional and societal context of the design objective as it relates to engineering standards and realistic constraints that include one or more considerations of economics, environment, sustainability, and manufacturing ethics, health and safety, and social and political impact. So you have to also make sure your objectives are clear. So clear objectives lead to clear plan for generating the task to accomplish the design goals. So next part is for the design strategy. So you have to describe your approach to this project. If your project calls for additional subsystem development, such as, for example, special purpose sensors, mechanical components, you should also discuss your design approach to these subsystems. So additional to that, you need to consider design alternatives and ways to evaluate them. You also have to include block diagram So block diagram may be helpful to convey how different components and stages in your design fit together. So in terms of the plan of action, so this consists of various tasks needed to implement the design strategy. The task should be linked to the objectives and the design strategy components. So the task should be divided among the team members for a well-rounded experience for all. So ayan, to be specific, one person doing all the analysis, another simulation, and another for implementation, and yet another for testing does not lead to well-rounded experience. So hindi siya ganon. So all must share these activities not necessarily and exactly the same portion. So for each task, you can designate one team member as the lead. And then lahat pa din is may input on each of the parts. So parang may isa lang na nagmamanage for that specific process or task, and then lahat pa din will provide their inputs. So next is for verification. So outline the task procedures of your project and resulting tables, graphs, and measured values that will assess the project performance. So this should be correlated with the project specification described in the introduction section. So you also have to describe the test procedure for individual project components and subsystem, like for example, model validation, sensor subsystem, and overall system. So as part of your project, you also have to describe the engineering components, subsystems, or parameters that most affect the performance of the project. So you have to discuss how you will later in the project verify this analysis. So as part of the schedule, so it is important that you know the different parts of the manuscript and how will you go through the design project mismo. So in scheduling, you have to include a timetable showing when each step in the expected sequence of design work will be completed. So this can be generally classified per week, and how the task will be shared among the team members. So before yun, so part of your scheduling, it is important that you are well aware on the contents of the design project. So i-run through lang natin to. So for the design project, yan, you can read all of the following contents para alam mo ano yung mga ilalagay mo dyan sa part na yan. Pero brief discussion lang natin are the specific components or parts naman. So we have intro, we have the methodology, design calculation and analysis. So you also have to provide tables and charts, project costing example table. So ito naman is syempre yung mga equipment na gagamitin nyo are yung mga available sa market with its corresponding component schedule ng mismong equipment na yun. So from that, you can, yan yung mga pwede nyo i-fill. So also, meron din namang price doon, so you can fill in the project costing example table. Then provide conclusion and recommendation and then bibliography. So, ayan, ito naman is for the part of appendices. So lahat ng mga nandito dapat nakalagay. Yung applicable or available na ilagay na nandito sa list, so dapat ando doon siya sa bibliography. So this includes sample calculations, derivations of equations, tables of data, equipment catalog, learning experience, project. So take note, this is learning experience is per member. So next is project documentations, screenshots of meetings, plant drawing, attached drawing table. So you have 2D and 3D models. So we have CAD system development, any process modeling that must be completed. So additional drawing development is yung detailed plan drawing, general equipment, auxiliary views, detailed elevation, and isometric drawings. So yan, may format tayo, paper size, margin, font, and spacing. Yan. So for letter of transmittal, nakalagay naman dyan kung ano yung mga purpose niya at kung ano yung mga dapat content. So title page and table of contents, executive summary. So we have the body of the report, format for the appendices. Ayan. Yung presenting the results, presentation, guide. Ito yung mga format for subheadings and paragraphs. So we also have formats for the table, format for the graph. And then, yan, illustration, pag may illustration, for nomenclature, references to the literature, Okay? So yan. And adding bibliography. Okay, format. So we also have here format for providing sample calculations. And then, ayan. So proofreading and checking. So yan, may engineering drawing. So checklist for the final report. So yon, after yan yung mga parts, and format for each of the part, paano nyo siya gagawin. So in terms of scheduling, so you can base the task here in design project format, where you can base all the tasks and then provide timetable. So after nyong matapos yung mismong manuscript for design project, you can ask the group of this following question para malaman nyo kung may kulang pa dun sa mga na-provide nyo. So does the report fulfill the purpose? Will it be understandable to the principal readers? Does the report attempt to cover too broad a subject, etc.? So again, yan, can be guided through that question. So also, meron din tayo ditong design rubrics. So 60 points is for the paper, and then 40 points is for the presentation. This is individual. Pero syempre sa paper para siya, pero for presentation, depende kung ano yung performance ng kada member of the group. Okay? So this design rubrics also, since nakalagay doon kung anong parang yan yung pinaka naging contribution ng kada member. So parang yan, magiging guide din yon kung saan magagaling yung 60 points nyo. So ito naman yung mga titingnan for presentation rubrics. We have the technical content, logical coherence and development, oral presentation, presentation materials. So saan makikita yung part ng kada member? So, okay. Proceed muna. Continue natin tong sa schedule. So in terms of scheduling, week 10 dapat nakapagpasa na, week 10 dapat may approved topic na kayo. Week 11 to 15 yung whole na pagtapos ng buong design project. Okay? So, make sure lang na magbigay kayo ng time for this proposal, for this design project, kasi again, this consists a large portion of your grade. So although this one is will be done by group, pero meron pa rin tayong individual criteria. Okay? So as for scheduling, so approved topic na dapat week 10. So you will be starting the paper and finish it. Start and finish is week 11 and week 15 respectively. So you almost have 5 weeks to finish the design project. So all of the contents that you needed are on the format of the design project uploaded in the Google Classroom. So there will be no problem. So in terms of this scheduling, so you can use that 5 week to schedule all of the tasks to finish the design project. So next is for the bibliography. So sa proposal, may bibliography since meron na kayo ditong yan. Sa part ng intro and other parts, you can include some of review of related literature that can support what you wanted to design. So yan. Aside from providing this doon sa ating research proposal, so ito naman topic proposal for this design project. So ito naman is nakalagay din doon sa part ng appendices natin. Wherein kailangan talaga isa-isahin kung ano yung nandito. So ito, learning experience, single page per member, and also you need to write the contribution of each team member, not only for this proposal, but also for the whole or dun sa final design project na nagawa nyo. Okay? So for this proposal, these are the questions you can ask for the group. So is the problem sufficiently important to justify money, time, and your effort? So next is the project well defined and realistic? And then have you outlined a sound approach, including your ability to perform the task? So ito pala, yan. So these are the questions you can ask yourself or your group, if doon sa proposal nyo ba, napakita nyo ba yan lahat? And then again, guided naman kayo sa lahat ng part ng proposal. So, due date ko dito will be on week 9. Pero yun nga, exam week yon. So, I'll adjust it on week 10. Pero may holiday doon. So, gagawin natin or yung due date natin doon is Wednesday, March 27 yun. No, so yun, enough time naman yun para makapagpasa kayo ng proposed design project. Para, ayun, isang gawaan na lang at ma-approve agad, hindi pag-aralan na agad siyang mabuti. Kasi, yan, you have enough time naman to do the proposal. Okay, you have 8 members per group and also some groups have 7 members. Eh di pagtulong-tulungan. And then again, you have to write each contribution. Each member's contribution then dito sa paper. And take note, include a brief paragraph on the contribution of each team member and take note that all team members must sign this page. Okay? Okay, so since this will be submitted online kasi baka hindi na kayo makapagkita-kita. So, dun sa signature dito, pwede siya na electronic or e-signature, pero dapat nakapresent yung screenshot na kita nyo lahat. Yung naging contribution ng kada team member. So, once approved, pwede naman na mag-request ako ng mismong signature na para lang makita natin kung talagang yun ba yung naging contribution kasi makikita din ng iba mong ka-group or mababasa nila. But kung hindi man magkakaroon ng face-to-face meeting bago ipasa at hindi agad natapos kasi exam week ngayon, so I'll approve naman kung e-signature mo na yung gamitin. Okay? Do you have any question? So again, submission natin is March 27. Okay? So make sure na mapasa nyo agad. At least I can use the holidays for checking or approving yung pinasa ninyo. Do you have any question? May tanong ba? Question, clarification?
Ma'am, may defense din po bang mangyayari sa design project po?
Ay, oo nga pala. Yung may defense yan. Yung kaya siya ipapasa ng week 15 kasi yung week 16 and 17 natin is allotted for defense presentation na. Okay? And then for the defense, or presentation, I'll request recorded, para at least na pag-aralan nyo na din yung i-present. Yun din is para kasi nga minsan nagkakaroon ng problema sa internet, di may iwasan. So para yung pagpe-present is dire-diretso siya. Hindi tayo maaano sa time kasi meron lang tayong limited time for presentation. So you will prepare presentation on your paper, and then yun, yung rubrics is nandoon. Wala naman siyang na time, pero yun nga, magbibigay na lang ako kapag malapit ng matapos. Kung kahit mga week 13 siguro, magbigay na ako ng ilang oras or ilang minuto kayo pwede mag-present. Okay? Do you have any question?
Ma'am,
clarification? Yes, okay.
Sa possible topics po, ang magiging coverage po ay para pong improvement or modifications po sa refrigeration system. Somewhere po doon.
Oo, or pwede naman, Pero depende din sa inyo. Kasi yun nga, mahirap naman na syempre lahat naman ng refrigeration system, yun nga, meron na siyang specific components. So pwede kayong ganun yung maging strategy wherein hanapan nyo ng ano yung pwedeng i-modify dun sa mga ano. Pero siguro replication and modification in each of the system, pero wala tayo dapat makikita na kagayang-kagaya ng ginawa nyo. Clear ba?
Okay po.
Okay. Any other question? Clarification? May tanong ba? Question po?
Wala po, ma'am.
So, yan. Start na tayo sa discussion natin. So, this is the last part ng topic natin for, eto, na-upload ko na din. Ano bang section niya? 05. So, na-upload ko na din dito yung sa design project. So, ito yung sa lecture natin. Last lecture natin for before midterm exam. Okay? So, di naman natin ito matatapos ngayon, pero we'll finish this next week naman, no? So, start na din natin. Still have 1 hour to finish. At kung hindi, then we'll continue next week. So, these are the compressors used in the refrigeration system. So, this includes systems and components, which includes evaporator and condenser. But most of the topics here are on the types of compressor and formula, computation for compressor. Kasi in terms of compressor, dapat alam nyo pa din paano i-compute yung work sa compression process. So nakadepende pa din yon kung anong type na compressor yung ginamit doon sa process na yon. So compressor is one of the most important component of the vapor compression system. So others like condenser, evaporators, and expansion devices has its own peculiar function that makes the system controllable. So since the compressor is the prime mover of the refrigerant circulating the system, it is commonly known as the heart of vapor compression system. So we have provided for most common type of compressor used in refrigeration system. So these are the reciprocating compressor, we have screw compressor, we have centrifugal and vane type. So magtatawag na lang ako kung sinong pwedeng magbasa. So ang mga type naman na to is na-discuss din ba to sa fluid machinery?
Yes. May
Ano yun?
po.
Ayun. So some of this are discussed na naman sa Fluid Max, especially yung mga computation. So yung iba dito is talagang review na lang. So kindly read this, Waris Renzo. The first type, which is the reciprocating compressor.
Reciprocating compressor. The reciprocating compressor consists of a piston moving back and forth in the cylinder with suction and discharge valve. So arranged to allow pumping to take place. The workhorse of refrigeration industry is the reciprocating compressor. Built-in sizes ranging from fractional kilowatts to hundreds of kilowatts of refrigeration capacity. Modern compressor are single-acting and may be single-cylinder or multi-cylinder. In multi-cylinder compressors, the cylinder are in V-type and double V-type, radial or inline arrangement. Reciprocating compressors dominates from a very small refrigerating capacity to about 300 kilowatts.
Okay, next number 2, Von Ajay.
Number 2, The screw compressors are rotary compressors that use rotating elements like a pair of screw inside stationary cylinders. This pair of screw provide positive displacements of gases on the discharge port of the compressor. Screw and small centrifugal compressor which battles for the market in the range of 300 to 500 kilowatts of refrigeration.
Okay, so next, number 3, we have centrifugal. Tristan.
Centrifugal compressors are compressors whose rotating elements operate to compress gases by virtue of centrifugal force. The centrifugal compressor is the choice for large capacity units, particularly for water chilling plants, used for large air conditioning installation. Centrifugal compressors are most widely used for units having refrigerating capacities of 500 kilowatts and above.
Okay. So, kung mapapansin nyo, meron na tayo dito. Kumbaga, alam naman natin in different types of compressors, and any other components, merong kailangan i-take into consideration. So in this case, more on the refrigerating capacity. So there are also lots of types of compressors that is used sa refrigeration systems nowadays. So kaya yung mga components na gagamitin nyo for your design project should also be discussed based on its previous use, yung paano siya ginagamit on some of the refrigeration system nowadays. So next is the hermetically sealed compressor. Kindly read this, Rio, Angela.
Hermetically sealed compressors are compressors whose motor and compressor are often enclosed in the same housing or common housing to avoid leakages at the seal. Improved techniques for insulating the motor electrically have allowed motor to operate even though they are in contact with the refrigerant. In many designs, the cold suction gas is drawn across the motor to keep the motor cool. Almost all small motor compressor combination used in refrigerators, freezers, and residential air conditioners are of the hermetic type. The only connections to the compressor housing are the suction and discharge fittings and electric terminals. Moisture in the system can be damaging the motor, therefore dehydration of hermetic units before charging refrigerants is essential. Condensing units are components of refrigeration systems specifically arranged to combine with compressor in most split-type air conditioner refrigeration systems. This unit is usually termed as outdoor unit of refrigeration system. The indoor unit consists of expansion valve and evaporator are located inside the room of a split-type air conditioner.
Okay, so here, on our compressor performance, in dealing with the compressor performance, ito nga yung tinitingnan natin, yung refrigerating capacity and compressor power requirement. So, meron tayong dalawa. Pero, this is the most important performance characteristic of evaluating compressor, pero syempre, meron din ibang properties. But in dealing with compressor's performance, we're looking for its refrigerating capacity and power requirement. Okay? Kung mapapansin natin, yun naman yung tinitingnan natin for COP, or coefficient of performance ng refrigerating capacity or refrigeration system. So these two characteristics of the compressors operating at constant speed are controlled largely by the suction and discharge pressure. So an analysis will be made first of an ideal reciprocating compressor because it gives clearer understanding of the effects of these two pressures or on these two pressures. Trends established from a study of the ideal compressor hold true for the actual compressor, although adjustment must be made in numerical quantities. So this adjustment will be examined in the discussion of the actual compressor. So the performance of reciprocating compressor are being predicted by its volumetric efficiencies. So we have two types of volumetric efficiencies. We have the actual volumetric efficiency and the actual and the clearance volumetric efficiency. So for the actual, alam naman natin that is V1 over VD. So the ratio of the actual volume flow rate entering the compressor and the volume swept through by the piston in their suction stroke per unit time. So that is VA over VT or V1 over VD. Kasi yung suction natin is VA. So that is the actual volumetric efficiency. So next is we have clearance volumetric efficiency. So in our previous formula, or in our previous discussion dun sa mga sample problem natin, inequate na natin tong dalawang to. So, discuss natin bakit. But, yon, tuloy muna natin discussion for clearance volumetric efficiency. So, this one depends upon the expansion of gas trapped in the clearance volume. So, this is a function of the clearance, percent clearance, and also the volume at the suction and discharge. So for isentropic expansion assumed between VC or the discharge volume, or volumetric or clearance volumetric efficiency is equal to 100 minus M multiplied by the quantity V1 over VC minus 1. So take note, V1 natin is yung suction, na V sub 1 pa din. So take note, we're talking about the compressor. So aware naman kayo kung nasan siya sa pH diagram. And yung VC natin is the discharge volume. Okay? So V1 over V2 minus 1 kung dun sa pH diagram na ginagawa natin sa numbering. So V sub suction is equivalent to specific volume of gas entering the compressor, and V sub discharge is the specific volume of vapor after isentropic compression to compressor discharge pressure. So, ito din yung ginamit naman natin sa calculations natin, no? So, we have 1 over 100 minus M multiplied by V1 over V2 minus 1. So, ito yung ginamit natin kahapon na 1 plus C minus C multiplied by the quantity V ng suction. So, that is V1 over V2. Or 1 plus C minus C in terms of pressure, that is okay, so this is in terms of pressure, P2 over P1, kasi P discharge over P1, raised to 1 over N. So what is M bago yun, no? M is percent clearance volume. So yun ay in percentage lamang. Kumbaga naka-multiply ng 100 yung clearance volume natin. Okay? So yung clearance volume naman natin is in decimal number. Okay? So PD naman is discharge pressure. So in our case, ginagamit natin state point 2 or P2. Suction pressure is P1 and is compression index. So if isentropic process, yung compression natin, so that is K. 1 over K. For ito yung actual and clearance volumetric efficiency relationship. The actual volumetric efficiency is equivalent to the clearance volumetric efficiency multiplied by efficiency sub S. So, saan lang galing tong efficiency? S sub S. So, this is equal to PC over TC multiplied by TS over PS. So, PC and TC are pressure and temperature at cylinder. So, PS at TS are pressure and temperature at suction of the compressor. So, if these items are not given, so therefore, yung N sub S mo, assume na 100% efficient. So therefore, we can say that our volumetric efficiency or the actual volumetric efficiency is equivalent to our clearance volumetric efficiency. Kaya natin siya ine-equate. Pag wala tayong pwedeng makuha na efficiency based on the pressure and temperature at the cylinder and also pressure and temperature at suction of the compressor. Clear ba tayo doon? Any question, clarification?
Wala naman po.
Ma'am, kapag po sa problem po, sasabihin po ba yun na pressure and temperature at the cylinder po?
Oo, naka-indicate naman yun.
Noted po ma'am. Parang hindi po siya yung hahanapin po dun sa mga table po. Ganun.
Hindi. Kasi yung suction at discharge pressure natin is ito yun. PS over TS. Ito naman is sa loob mismo nung compressor cylinder.
Noted po ma'am. Thank you po.
Okay. So next naman natin are the thermodynamics work of compression. So if nakastate sa problem natin, kung it undergoes isentropic work of compression or polytropic work of compression, so we can use this following formula to get the work, and not get the H2 kasi yun yung normally, or based on heat balance, yun yung isa, yung H2 minus H1. But again, if it undergoes this following process, yung isentropic, actually pwede din natin siyang gamitin if we know the value of K, or it is given in the problem. No. So if for example, ganun din naman yung gamitin nyo, hindi naman nalalayo yung sagot. So we have isothermal compression, isentropic and polytropic. So for isothermal, so this is a constant temperature compression of gases. So yan, review lang natin. Isentropic work of compression is a constant entropy compression of gases. So next we have polytropic compression. So this is a compression whereby the compression index N is specified at a given compression of gases or line of compression. So given siya on the PV diagram between isothermal and isentropic line of compression. So here are the corresponding formula if it undergoes isothermal compression. So yung sub S is suction, meaning in our pH diagram na ginagawa normally bago pumasok ng compressor, ang state point natin is, ang ginagamit natin is 1, ang paglabas ay 2. So, ganoon din naman yan, walang pinagbago. No? So, this can be P1, V1, Ln ng P2 over P1 for isothermal compression. For isentropic work of compression naman, that is equivalent to K, wherein this is the isentropic compression index, K over K minus 1 times PS Vs or P1 V1 multiplied by P2 over P1 raised to K minus 1 over K minus 1. Okay, so N lang yung gagamitin natin kapag ka polytropic compression index, but the formula is the same. No, maliban dun sa compression index na ginamit. So isentropic is for, K is for isentropic, N is for polytropic. Okay, so do you have any question on this item? May tanong ba? Clarification?
Ma'am, question po.
Yes, John.
Sa polytropic po is lagi pong given yung N.
Oo, pero in a case na pwede siyang given yung N, or kaya naman sinabi sa problem na polytropic process siya. Naintindihan? Pero, yun nga, kapag actual vapor compression cycle siya, so alam naman natin, hindi na siya isentropic compression. So naka-indicate na doon kung ano yung process doon sa work of compression or yung compression process. Okay? Naintindihan ba?
Ay ma'am, what if hindi po nabigay yung N po na value? Ano po kaya yung gagamitin namin? Given po na polytropic po yung nakasaad po sa problem.
Siguro doon sa problem, there's a way na mahahanap mo yung value ng N. Constant, hindi siya constant. Depende siya sa yun, sa process. Ang sinasabi natin na constant, yun na yung isentropic compression index na K. Yun yung nahahanapan natin ng constant. So, di siya constant. So, given siya sa problem or pwede siyang kuhanin. Any question? Okay, any additional question? May tanong ba? Any question? Clarification?
Wala na po siguro.
Okay, so next tayo. So here is a example performance of an ideal compressor. So in the ideal compressor, the compression of gas and the expansion of gas trapped in the clearance volume are both isentropic. So the only factor that influences the volumetric efficiency of the ideal compressor is the expansion of gas trapped in the cylinder head of the ideal compressor. So to show the effect of temperature on clearance volumetric efficiency, we're going to apply our data with the performance of ideal refrigerant 22 compressor, displacement rate of 50 liter per second, and we have also 4.5% clearance and 35 degrees Celsius condensing temperature. So to practice our calculation capabilities, let us fill up the accompanying table and plot the curve for volumetric efficiency and mass flow rate. So ang ipagagawa ko na lang sa inyo is itong table na to. Pero may laman na naman siya. So itry nyo lang sa inyo kung magiging tama yung mga laman nito. So paano ba siya i-compute? Ano ba yung formula natin for clearance volumetric efficiency? So that is 1 plus C minus C. So given naman yung discharge and suction pressure multiplied by 1 over K. So ang wala lang tayong value dito is yung 1 over K. You can use 1.7 and clearance of 4.5%. Okay, so yun. I'll give you 15 minutes dito sa table na to. Okay, so kahit may sagot na yan, itry nyo pa din kung magiging tama. Tapos sabihin nyo mamaya kung may discrepancy dyan na nagkamali. Okay, para alam nyo din paano i-fill tong table. So for mass flow rate in kilogram per second, so meron naman tayong binigay na specific volume dito. Do you have any question? Clarification? May tanong ba?
Wala naman po, ma'am.
Okay, so try muna natin to. And then, yan. Balik or discuss natin at ano ba to? Yan. Ano bang oras? 12:40. No? Okay, may tanong ba? Yung iba may tanong? Okay, taas muna tayo ng kamay kung clear naman yung gagawin. Okay. Hands down and then continue na muna. So again, yung K natin is 1.17. So ang clearance naman is nakabigay dito na 4.5. Okay? Justin, may question ka?
Wala po, ma'am. Late na raise hand.
Okay. Okay. So continue muna to. Okay, hello. Nakuha ba?
Opo, ma'am.
Okay. Meron bang describe kayong nakita? Same naman ba? Same ba yung value na nakuha nyo sa lahat ng mga nandito sa table or merong mali?
Same lang po, ma'am.
Okay. So, let us now proceed. So, ito naman is the plot of the datas that shows a curve of clearance volumetric efficiency and the mass flow rates. If you graph it, then ito yung ipapakita niya. So this is the relationship of the evaporating temperature, the clearance volumetric efficiency, and the mass flow rate. So itong part na to, okay, so next naman is itong power requirement of the ideal compressor. So, yun nga, if meron tayong enthalpies given at each state point ng ating compressor, then we can get the ideal power requirement for the compressor, which is equal to the mass of refrigerant multiplied by the change in enthalpies. So, enthalpy or H sub D is the discharge enthalpy and the H sub S is the suction. So, in our case, this is H2 minus H1. Okay? So, ito namang part na to ay skip na natin. Okay? So, next, kindly read this slide. Wait. Lance Gerard. Slide. Itong unang paragraph pala. Lance Gerard, kindly read this first paragraph. Capacity control on compressor.
Hello po, ma'am. Rinig na po ako. Hello po, ma'am. Okay. Capacity control on compressor. If a refrigeration system is operating in a steady state mode and the refrigeration load decreases, the inherent response of the system is to reduce the evaporating temperature and pressure. This change in the evaporator condition results in reduced compressor capacity, which ultimately matches the reduced refrigeration load. The reduction in evaporator temperature may be undesirable for several reasons. In air conditioning, the coil may collect frost and block the airflow, further reducing the evaporator pressure. Stored fresh food and many other products may be damaged by low temperatures. If the evaporator chills the liquid may freeze and burst a tube in the evaporator.
Okay. So next is this method's used in order to reduce the compressor capacity. So ano ba yung tinatawag natin na compressor capacity? So kindly read this slide. Kimberly Joyce. Etong 1 to 4.
Methods used to reduce the compressor capacity. Number 1, in cycling, the compressor stops and starts as needed. The methods work well in small system. 2, back pressure regulation throttles the suction gas between the evaporator and the compressor to keep the evaporator pressure constant. This method gives good control of evaporator temperature but inefficient. 3, bypassing the discharge gas back to the suction line usually affords precise capacity reduction, but the method is inefficient in the compressor runs hot.
Sa akin lang ba na-disconnect ata si Ning? Hindi ko marinig.
Nawala po, ma'am.
Nawala ata siya.
Sorry po ma'am, na-disconnect po. Saan po ako na-tap? Na-disconnect po. Hello po. Okay na po.
Okay na. Kahit mag-start ka na lang dun sa 2 ulit.
Sa 2 po.
Start ka na lang dun.
Word 2, back pressure regulation throttles the suction gas between the evaporator and the compressor to keep the evaporator pressure constant. This method gives good control of evaporator temperature but inefficient. Bypassing the discharge gas back to the suction line usually affords precise capacity reduction, but the method is inefficient in the compressor opens runs hot. A preferred bypass circuit delivers the discharge gas that is bypassed back to the entrance of the evaporator. 4. Another method is cylinder unloading on a multiple cylinder compressor by automatically holding the suction valve open or diverting the discharge gas from cylinder back to the suction line before compression. In reciprocating compressor of 2 heads, 2 horizontal lines carrying high pressure oil from the oil pump at the right end of the compressor to hold the suction valves open when the unloaders are activated. The loss in efficiency with cylinder unloading is moderate, as step control may be provided with unloads more cylinders as the suction pressure drops.
Okay, so thank you, Neng. Ayan. So, can you read this for rotary compressor? Alex?
Rotary compressor. Rotary compressor used in the refrigeration system include screw compressor and vane type compressor. A screw compressor has 2 rotating elements. The male rotor, which drives the female rotor inside the stationary cylinder. The refrigerant vapor enters one end of the compressor at the top and leaves the other end at the bottom. At the suction position of the compressor, the void is created into which the inlet vapor flows. Just before the point where the interlobe space leave the inlet port, the entire length of the cavity or gully is filled up with gas. As the rotation continues, the trapped gas is moved circumferentially around the housing of the
Ayan. You can continue na.
the trapped gas of the compressor. Further rotation results in meshing of the male lobe with the female gully, decreasing the volume in the cavity and compressing the gas. At a certain point into the compression process, the discharge port is uncovered and the compressed gas is discharged by further meshing of lobe and the gully. The screw compressor was developed in 1930s and first became popular in refrigeration service in Europe in the 1950s and 1960s. Many screw compressors are equipped with sliding valve for capacity control. It is in the housing of the compressor and can be moved axially. As the valve is opened, it delays the position at which compression begins. The capacity can be modulated down to about 10% of full capacity, although there is loss in efficiency in the capacity reduction. The best screw compressor efficiency is in the range from 70 to 80%. That is dependent on pressure ratio and the built-in volume ratio of the compressor.
Okay. So, thank you, Nen. So, for these different types of compressor, para ito kasing in-explain dito or its function, paano siya gumagana. So, you can watch the animation. Madami namang related na animation dito para mas madali nyo siyang maintindihan. Pero, I'm sure, na-discuss ba siya sa Fluidmac? Ayun. Kung hindi man kayo nakakita ng actual, ay di manood na lang ng mga animation para alam nyo din kung paano siya gumagana. And ano yung itsura niya mismo. Okay? So, I will assign na lang pala per group who will share and search for the animation na lang and then send na lang sa GC yung link. For group 1, assign muna natin. Tapusin muna natin to hanggang sa centrifugal. So for group 1, centrifugal, group 2 naman is vein type compressor naman. So yung pinakamaikling video lang ng animation. So again, yung group 1, centrifugal, group 2, vein type. And then I'll sked yung ibang compressor sa iba after natin dito. Okay? So kindly read this, Jean Ira.
Ma'am, si Jean Ira daw po ay may internet issues.
Okay. How about you, Bea Joy, Evangelista? Kindly read this slide.
The two basic type of vein compressor are the roller single vein type and the multi-vein type rotary compressor. The components of the single vein type are shown in figure 4.3 below. It has a stationary casing cylinder, a rotor or roller, which is a rotating element, a spring-loaded vein, which is always in touch with the rotor, the intake port, and the discharge port.
Okay, so ito yung niya. So next naman natin is multi-vein vein compressor. Eliza, Marie, can you please read this slide? Eliza, Marie. Wala ata si Eliza. Okay, about you, Aaron Rayner.
The components of multi-vein compressor compared to single vein are stationary cylinder, rotating cylinder, intake port, discharge port, and two or more number of vanes. See figure 4.2 for two vein compressor physical components.
Okay, so yan. Okay. So again, this figure 4.4, 4-4 shows two vein. Yan, two vein compressor. And its physical components. Ito naman is single vein type compressor. So I'll assign muna para at least mapanood nyo din yung mga animation. Wala naman ang video naman na yun ng mga 3 minutes or 2 minutes lang or may 1 minute nga. So assign ko na lang 1, group 1, centrifugal. Then group 2, single vein. And then group 3, multi-vein compressor kung meron, no? And then for rotary compressor, so meron din siyang type na screw. So group 5 ay screw compressor. Parang ang group 6 hermetic. May iba pa bang hindi na? Ayun. Hermetic, group 6, and then yun na lang pala. Wala palang group 7. Yung reciprocating compressor naman is alam na natin. Pero ayun, kung merong gustong mag-share din ng reciprocating din, you can share din dun sa ating GC. Clear ba tayo doon? Pataas naman ako ng kamay kung clear tayo doon. Animation lang, marami naman sa YouTube. Share na lang dun sa ating GC. Anytime this week, bago tayo mag-proceed sa discussion natin ng pwedeng mag-search na kayo ngayon, and ipasa na lang sa GC natin kasi we still have 10 minutes naman. So yun, pa-search na lang ako and then pa-share sa GC. So, hands down. Do you have any question? We will continue to discuss this lecture. Nasa centrifugal na tayo next week. Okay. Do you have any question? Clarification? Yes, Bea.
Regarding lang po sa PSET, ano po yun? Sama-sama na po sa isa pong file, PDF file yung lesson?
Yung lahat ng naiwan. Pagsamasamahin na sa isang file. Nag-upload na ako dun sa Google Classroom. Yun yung part 2. Edi yung lahat ng hindi napasama dun sa part 1, sasubmit nyo ngayon.
Thank you po, ma'am.
Any additional question? Okay, so if wala nang tanong, goodbye class and see you on Saturday.
Salamat po, ma'am.
Thank you po,
Thank you po, ma'am.
Thank you po.
Bye.
Thank you po, ma'am. Salamat po, ma'am.